Okay everyone, so this is AMTA Learning with Mr. X. So today we're dealing with physics, just starting from grade 10. We'll see how we end, but we'll proceed up to grade 12 as you proceed going through the videos showing the course of physics. Okay, so now the first thing that we're going to look at is the scientific measurements. But before we start the scientific measurements, what do we understand by physics? So physics in itself, this is the study of matter and the energy it possesses. So now, let's now proceed to scientific measurements. So now, when we look at this point, let's see what we understand by base and derived quantities. So now, what is a base quantity? So a base quantity, this is a quantity that is not a combination of two or more other quantities. And basically, there are 7 base quantities. Number 1, we have length, we have time, mass, temperature, electric current, we have luminous intensity, then we also have amount of substance, which is the mole. Then when we talk about derived quantities, we are talking about quantities that are a combination of 2 or more base quantities. So derived quantities can come from these 7 base quantities when combined. Now, what do we understand by a physical quantity? So a physical quantity consists of numerical magnitude and unit. When we talk about the magnitude, we are talking about the size. Then the units that are going to be used will depend on the quantity we are dealing with. So now, all physical quantities can be grouped under base quantities or derived quantities, of which we have discussed what a base quantity is and what a derived quantity is. So now, a physical quantity, this is any measurable feature or property. Okay, so most units commonly used are a combination of base quantities or units. So they are known as derived quantities. So in most cases, we have a lot of derived quantities compared to the base quantities. So some of the examples that we can have that are derived quantities are velocity. So velocity is a derived quantity, acceleration, force, energy, even other things like work, moment, momentum, as well as pressure and many more. So the internationally accepted metric system used, it is what we refer to as the system of units, which is SI units. So SI units stands for International System of Units, which are units that are accepted worldwide or internationally by scientists. As physicists, we know it is very important to know the units and the quantities. So now let's look at some more SI units that we should take into consideration. So now, the numbers or values of physical quantities is written as a number followed by a suitable unit. So here we're having a table which is showing some of the base quantities and the SI units and symbols that we use. So one, we have length, which is a base quantity. The SI unit used, it is meters, symbol M. Then we have the other base quantity, which is time, unit second, symbol S. We also have mass, units, the SI units, which is kilograms. Then we have the the symbol for kilograms, which is kg. Then we have temperature, the units we use, it's Kelvin, and the symbol, it is capital letter K. Then we have electric current, the SI units are the ampere, then the symbol we use, it is A. Going to these other base quantities, we have luminous intensity, which is measured in candela. Then we also have the amount of substance measured in moles. So the amount of substance is measured in moles. Luminous intensity is measured in candela. Candela, we use the symbol which is CD. Then the amount of substance, the units which are the moles, we just write MOL. Small letter M, then small letter O, and small letter L. Like that. So now, from this, let's look at the next thing. So the next thing we're going to look at now, it is scalars and vectors. So now, what do we understand by a scalar? So a scalar refers to a quantity or physical quantities which have only magnitude. So some of the examples of scalars, we have length, time, mass, distance, speed, volume, density, and energy. So all these, they only have magnitude, they don't have direction. Then the next thing that we're supposed to know, it is vectors. What do we understand by a vector? So vectors refers to physical quantities with both magnitude and direction. I remember in the first place we described what magnitude means, and which is size. Then some of the examples of vectors, we have displacement, velocity, acceleration, weight, force, moment, and many more.